Number 5 is another graphing calculator problem. Little twist this time. Again, we're given the velocity function and we're asked to find the position of the particle. We're asked to find the position of the particle when the velocity is first equal to 0. And we see that our domain is at time is greater than or equal to 0. So for starters, we need to go to the graphing calculator, which I'm going to bring in now. And we need to find out when the velocity is first equal to 0. So we're going to put our velocity function into y1. And when we go to the window, we want to start at an x-min of 0. The x-max isn't all that important. I just made it 4. But we don't want any numbers less than 0 for the x-min because we're told that our domain begins when t is greater than or equal to 0. So if we take a look at the graph now, here it is. Okay, so the first time that this velocity function is equal to 0 would be at that point right there. We have to identify that point. Remember, that means we need to use our 0 finder. So we're going to hit second and then trace. That brings up our 0 finder. And it looks like it's happening at 0.6-ish. So let's just make the left bound 0 and the right bound 1. All right, so we're looking in between 0 and 1, and like I said, 0.6 or so. And in fact, it's 0.6551364. All right, so that is going to be, that's the position that we want. So we're interested in the position of the function at 0.6551364. Okay, so the position at that time will be equal to the position that we already know, which is 3, so that's x of 0, which is 3, plus the integral from 0 to 0.6551364 of our velocity function. So it's the same idea as the problems on the previous side, except that we just had this very difficult upper bound that we had to find first. Okay, so we know that x of 0 is 3, and then so we're going to do 3 plus the integral from 0 to 0.6551364 of cosine of 2 minus t squared dt. So we go back to the calculator, both on the screen here. Okay, and we're going to go to our put out here, and so we have 3 plus, and then math 9, and we're going to go 0 to 0.6551364, and we have the cosine. Actually, we don't have to put that in there. We can do y1. So alpha trace y1 dx, and when we hit enter, it gives us 2.816. So we can see that our answer is going to be C. For number 6, same idea, except now we're no longer in the particle motion category. We're just given a derivative of a function, and we're asked to find the function's value at f of e if we have this initial condition. So again, f of e is going to be f of the square root of e plus the integral from square root of e to e of f prime. Okay. That's what we have to calculate. Now this one we have to do by hand. Right, we can see because we have no decimals to work with. So 1 over x is the natural log of x when anti-derived. This is 2 over x, so this is going to become 2 times the natural log of the absolute value of x. So f of the square root of e, we're told is 5. So we have 5 plus, and then again, that 2 is a coefficient. So in essence, you can put that 2 out front if you want, and then just make that a 1, and 1 over x becomes natural log of the absolute value of x. But again, that 2 is still out front. So whichever way you do it, as long as you end up with this as your antiderivative, you're fine. That's being evaluated from root e to e. All right, so we have, just going to move down here, we have 5 plus 2 times the natural log of e minus 2 times the natural log of the square root of e. All right, and we need to calculate what is going on here. Okay, well, the natural log of e is 1. So this is 2 times 1, so this is 5 plus 2. So we have 7 minus twice the natural log of the square root of e. All right, so the question is, where does this line up with those? So we got to do a little more pre-calculus here. We have the natural log of the square root of e. So the square root of e, that is really e to the 1/2 power. So we have 7 minus 2 times the natural log of e to the 1/2 power. Now we know from our logarithmic properties, the natural log of e, they wipe each other out, and the 1/2 comes down to the base level. So this is 7 minus 2 times 1/2. 2 times 1/2 is 1. 7 minus 1 is 6.